Okay, in this lecture we want to talk about the Wronskian. This is a very specific topic, so this is going to be just a very short lecture, but it's a useful tool when determining linear independence of solutions. So basically, to look at it, the Wronskian is defined by a determinant, and we'll talk about determinants and matrices later on this semester. I'm assuming most of you know fundamentally what a determinant is. The definition is if we have n different functions, and those are differentiable n minus 1 time on some defined interval. So this is kind of some math speak here. And we're going to let k, and the functions are defined as f with a subscript k, where k is going to run from 1 to n. Then the Wronskian of the functions has the following definitions. So remember, f is your function. So this would be your function f1, this would be your function f2, and so on up to your function fn. And then the second row of the matrix is the first derivative of that function, the third row is the second derivative, and so on up to the n minus 1 derivatives. So this is going to make a square matrix, meaning that it will have a determinant. And if you take the determinant of this matrix, this is also sometimes called a fundamental matrix. Then you have the Wronskian. And without going into a lot of proofs or definitions, basically, if these functions are linearly dependent, then if you find the Wronskian, it will be equal to 0. So the converse of that is, if the functions are linearly independent, you want to show that the Wronskian does not equal 0. So as long as you get a non-zero value for this determinant of these functions and their derivatives, then you've basically proved that they are linearly independent. Now, determinants, this is just a simple example of what you would do with a second-order differential equation. So where this is useful is if you have, remember a second-order differential equation, we're going to get two solutions, y1 and y2. And then we have to show that those two solutions are linearly independent in order for them to form a basis set for the differential equation. So to find the Wronskian of those two solutions, you basically take y1 and y2 and then the derivatives of y1 and y2, put that in a square matrix and find its determinant. And if you remember, for just a 2 by 2 matrix, the determinant is the difference of the cross product. So it's y1 y2 prime minus y2 y1 prime. So if we evaluate that and we get a non-zero value, then the Wronskian is non-zero, and in fact the solution set does form a basis of linearly independent solutions to the differential equation. So evaluating the Wronskian, especially in lower order differential equations, is a quick way to determine that your solutions are linearly independent. And that's it for this lecture.